right, so we were just wrapping up this last law of cosines problem. So let's go ahead and do that. Let's wrap that up. Um, we were here where we had 25, and basically when you work this out, the 25 squared is 625. The 18 squared plus 10 squared is 424. The 2 times the 18 times the 10 turns out to be minus 360 cosine of C. Now what you need to do is you need to subtract this 424 from both sides, and then we're going to divide both sides by the negative 360. Okay? When you do that, so you get 201 here, 201 equals that negative 360 cosine of the C. And then in the end, it turns out that the cosine of the C equals, when I divide both sides, is a negative 0.5583. Don't worry about the negative. When we do cosine inverse of that, our angle turns out to be 124 degrees, which is perfectly useful, perfectly good, 124 degrees. Okay, so now we have to then solve for the other side. Now we can make law of sines work. So now we can say 25 over the sine of 124 equals, and we just have to figure out the other one, equals, let's say, 18 over the sine of A. And again, you're going to have to use sine inverse. So you're going to have to here go, really technically it's going to be the sine inverse of 18 times the sine of 124, and then that divided by 25. And it's going to be the sine inverse. What I got for that measure of angle A there was 37 degrees. Then that makes that the measure of angle B with the 180 rule says the measure of angle B has to be 19 degrees. Okay? So now, I have some of our area formulas here. So here we're working on our area formula, and you kind of have to just decide what you have here. So here I have angle C, I have side C, and I have angle B. So what happens when I have two angles and a side? And actually, technically, I have three angles, because quickly I can say, hey, 180 rule tells me this has to be 45 degrees. About 45 to 43 degrees. Sorry, I have to calculate here. 43 degrees. Okay, I have three angles. So three angles tells me I'm going to be using one of these where I have all three angles. And actually, the one I need to use is the first one here. Excuse me. So this is the one I'm going to be using right here. I'll kind of circle it. This is the one I want to use. Is that 1/2 of C squared sine A sine B sine C. So my K equals 1/2. C squared is 32 squared. And then I have sine of A, sine of 92 over, oh, sorry, that's the one that needs to go in the denominator. That's sine of C. Sorry, sine of A is sine of 43, sine of 45, all over sine of 92. Okay, now that I have that, I just need to calculate the right answer out here. It's really just a matter of putting it into the calculator for yourselves. I got 247.1. For the next problem, now let's do this in a different color here. Let's do this one in red. Now for the next problem, I kind of have the SAS again. All right, I have a side and the angle inside and the side on the opposite. With that one, you're going to be using one of these answers right here. This is actually the one we're going to be using here. So now my area is 1/2 times those two sides multiplied together, 5 times 9, times the sine of that included angle, the sine of A. Okay? And again, here it's just about chugging out the answer. Answer would be here 8.4 units squared. I'm not so worried about that unit squared. So next one, I have two sides and the angle not included, all right? And this one's kind of an interesting thing. I'm like, okay, wait a minute, where can I look at this? So I was looking at my different area formulas. Which ones do I not need? All right, all of these where I have two sides, I need the angle in between them. I need SAS. This one I need SAS. It's like, oh, I'm missing something here. So this is kind of a challenge problem. And then I actually need this side first. I need to figure out that side. So my first step is actually to use law of sines first to say what is my side A here. And so that's side A over, oh wait a minute, I wouldn't have side A over angle A. So I actually have to find side C first. So I need angle, oh sorry, I even messed up here. I need to find angle C first. Let's figure, oh, because I don't even have that. I have to figure out this angle C. So I'm going to say sine of C here over 15, my side. And then what happens is the measure of that angle turns out to be, what did I get? 29 degrees. So it's the sine inverse of 15 times sine of 110 divided by 29. All right, and that turns out to be, so this is 29 degrees. Now that I have that, now I can say, no, CB, C and B, and I don't have angle A yet, though. I'm trying to think to myself, okay, what do I do? I don't have my angle A. Oh, but I can figure out my angle A. My angle A here would be 41 degrees because of the 180 rule. Now I have the included angle. So now if you say, okay, I'm looking at this side here and this side here, and then the 41 is my included angle. So now it kind of appears that my best bet is the formula to use is to say that 1/2 times C times B times the sine of angle A, the included angle. All right, so that SAS, I finally was able to kind of figure it out. Challenge problem. I don't see one like this on the test, but well, you never know. I don't think that's going to be on the test though. All right, so here it would be 15 times 29. You could have also used, nope, I think this is about all we want to use, times the sine of that 41 now. In the end, 142.7 is what I got. Last problem here, let's look at this. Now we have all three sides, but no angles. This is the HEROES formula. This is where first we need to calculate that semi-perimeter, 7 plus 8 plus 5, and we're dividing it by 2. My semi-perimeter here is 10, okay? 7 and 8 would be 15 plus 5 is 20, 20 divided by 2 is 10. So now my area, if you remember, is you take that semi-perimeter, that S, and then you look at the difference. 10 minus 7 would be 3. 10 minus 8 would be 2. 10 minus 5 would be 5. So I'm taking the square root of all of those multiplied together, and I get 17.3. Okay? So there's a lot of different questions on this test. Don't forget that there's always a thinking question, or kind of a like put it in your own words type of question. For that, I'd really think about the idea of when do we use law of sines and when do we use law of cosines. And my suggestion on that is, will you use law of sines when you have an angle measure across from a given side measure? You use law of cosines basically when you have that SAS, when you have two sides and the angle in between, or when you have SSS, all three sides, but nothing else. So those are when you use law of cosines, and be clear about that in your head. There's your little treat and your trick for the test coming up.